All right, so in this video, I'm just going to briefly recap. This is actually an update to the first video that I did that talks about how to identify the number of molecules and the number of atoms in a chemical formula. So the first one I want to look at is this. This is something I noticed in the homework. There was a little bit of an issue with. People were getting a little bit confused with the hydrogens. So in this case, we do have hydrogen listed here and hydrogen listed here. Now the way this chemical formula is written, this hydrogen is actually part of the hydroxide. Okay, but the hydrogen is still present in the molecule and therefore it should be counted. So in terms of carbons, hydrogens, and oxygens that we have present, we have 2 carbons, 5 plus 1 is 6 hydrogens, and 1 oxygen. Now, in terms of how many of the molecule we have, there is no coefficient here, therefore it is understood that we have 1 molecule. Over here we have the molecule potassium nitrate. So looking at potassium nitrate, we notice here there is a subscript next to oxygen. So first of all, in terms of the number of molecules, we have 3 potassium nitrate molecules. Okay? Now, to identify how many of each element we have, we take the coefficient and we actually multiply it by each individual subscript. So we have 3 potassiums because 3 times 1 is 3, 3 nitrogens, but now we have 3 times 3 is 9 oxygens. So if we had to build 3 potassium nitrate molecules, we would need 3 potassiums, 3 nitrogens, and 9 oxygens. Now looking at this last one, there are a few things I want to point out here. This part of this reaction, these are called the reactants, and you must know the difference between the reactants, and this part is called the products. Okay, so reactants go into the chemical reaction, they're what is reacting, and the products are the end result of the chemical reaction. So in this particular case, in addition to pointing this out, notice how carbon dioxide has a prefix, a coefficient, water has a coefficient, oxygen here has a coefficient, but glucose does not have a coefficient. I did notice a few people carrying coefficients across plus signs. The coefficient belongs only to the molecule that it is in front of. So this coefficient belongs only to carbon dioxide. So if water did not have a coefficient in front of it, this would not be related to it in any way and it would not transfer across the plus sign. So please don't transfer coefficients. So now, if we're adding the number or identifying the number of molecules we have 6 carbon dioxides, we have 6 waters, 1 glucose molecule, and 6 oxygens. Okay? Oxygen molecules. Now, to identify how many of each element we have carbon, oxygen, and hydrogen. So carbon, hydrogen, and oxygen. On the reactant side, we have carbon here, there are no carbons here. So 6 times 1 is 6 carbons. The hydrogens are next, so 2 times 6, we have no hydrogens here, so 2 times 6 is 12 hydrogens. And 6 times 2 is 12. And 6 times 1 is 6, So we have a total of 18 oxygens in the reactants. Now, let's take a look over here. Here we have 6 carbons. There are no carbons over here, so 6. Hydrogens, there are none over here. We have 12 here. And 6 times 2 is 12. And 6 oxygens. We have 18 oxygens over here. Now notice on this side we have 6, 12, and 18, and on this side we have 6, 12, and 18. The reason for that is because the law of conservation of matter states that matter cannot be created or destroyed. It can only be converted from one form to another. So even though they are not in the same order, they are not in the same compounds, all of the elements that have gone into the chemical reaction are represented in the products of the reaction. So I hope this helped understand a little bit about determining the number of atoms of a particular element and determining the number of molecules that exist in a chemical reaction.